Good afternoon. I am seeing only 7 of us here. I'm going to give another 5 or maybe 4 and begin at 20 past 5.
Okay, so
All right, good afternoon again. Now, there are three things that I need to do today. I need to do one, and I won't tell you all three of them all at once, but the first thing I need to do is to look at a homework question I gave you on differential equation. On Tuesday of last week, I sent you some notes with a one question as I do now. Have you all done it?
No, sir.
Yeah, do me a favor now, please. Can you take 5 minutes and go through the question now, please? I ask you to take 5 minutes and go through the question right now for me, please. I need to close off that. I have one final thing to do. And that final topic has many other topics in it. Final unit has many other topics in it.
I'm driving, sir.
Okay. What about the others?
Didn't get the chance to do it, sir.
No problem. You can start now for me, please.
Sure.
Thanks.
Good evening, sir.
Hey, how you doing? I gave a one question last class. Did you do it? Oh.
Sir?
Yes, sir.
Uh, they're waiting on that time to start.
No, man, I gave, hold on. Let me disconnect. I gave a piece of work last week Tuesday, a differential equation question, but when I canvassed the class, nobody did it, so I'm giving them time to complete it. So they have about another 3 minutes or so to finish it. Did you do it?
Sir, which question, sir?
Differential equation. The last handout I sent. Find it?
Yeah.
Mhm. Match it up for me, please. Are we finished now?
Sir.
Yes, Papa.
Send me a WhatsApp message.
Oh, you did? All right, cool.
Sir, I'm kind of stuck.
What's up? What's up? Why stop?
I don't know what to do with the two.
You don't know what to do with the two.
Yes, sir.
I could say if it's the same two that I'm thinking about, I could say
Yes, sir.
yes, Papa.
I'm stuck too.
Is it a two for you too?
Yeah.
All right, that's no problem. All right. So some of you having a two problem. I'm seeing some responses that are very, very, very good. I'm extremely proud and happy. I like it. I like it. But be careful of that too. I'm going to give you 2 more minutes for those of you who are still making an attempt. 2 dege minutes. And I don't want anybody to sit here and not doing the work, you know. Okay. I kind of have some news I want to share with you that I learned about today, but I'm going to keep my mouth and not say nothing to it. But I am praying that all will go well for your sake. So I'm very hopeful though.
Semester extend, sir?
I wouldn't want that to happen. You see, any other semester extend my own way. I cannot live with another extended semester.
You need one, sir. You need one.
You need one for what?
You need to still.
No man. The extended semester mash up my mates. Me not lie you. Oh goodness gracious.
Why, sir? So you will want to get you that way?
No. Far from the truth. That's why I'm saying to you that I have something to share, but I can't share it yet. It's going to be it's going to be fabulous news for you, but I can't share it yet. Because sometimes I have some snitches around us. I'm not calling in a snitch, but somebody may get too excited.
Sir, PM, sir, PM.
Yeah, all right, cool.
Direct message me then.
Private message, DM. All right, I hear you. No, it's all right, man. But I'm very hopeful. I'm very excited. I really want it to happen, and I'm just looking forward to it. So, I want to soon hear about it because this is going to be in earnest. When it busts, then we can tell you, say, boy, trust me.
Say better, you never say no, though.
Because on the suspicions, I ripe up down and I wonder what the man.
Sure, please. Please,
And
may I go through a rough patch? Just make me feel nice.
and guess what? No, and guess what? I'm saying to you, if you're going through this rough patch, you can just stop thinking about it because this one going to kind of soothe it. Trust me. When I say it's going to soothe it, it's going to soothe it. All I'm going to say to you guys, as it relates to separating apart, changing topic, changing topic, and I'm moving to your your mid-semester. You notice I don't come to class and say anything about what about the test support and so on, because I recognize on a Friday, on a Tuesday, well, some people are at work still and some people are on their way home. So that's not what I'm referring to, not the mid-semester, but I'm just saying this to you. I recognize when I look at Edico that some of you are pussyfooting around completing the assessments. Some of you are pussyfooting around completing the assessments.
So overwhelmed, this big man thing.
All right. No, but guess what? I was going to tell you something, Papa. I was in a meeting today, same meeting for which I spoke out. On Friday of last week, I started my last unit for my CAPE students. My last unit for my CAPE. Only Friday of last week. Only Saturday of last week that they got their SBA. As I'm working with you, I am working on the SBA, doing the calculations, because the poor students them at loggerhead. And for those of you who have family members doing the CXC exam, you'll hear the row that we're asking for an extension and CXC them nagging an extension. Think of the difficulty that I'm in. My CAPE students have exam on Monday of next week. I don't finish teaching the syllabus. Now, if you know me well, I don't come to class and waste time. I don't come to class and waste time. We may have a little one or two, but guess what? Work time or work time. But they started school the 25th of October. So while we are going through Calculus 1, meaning that teaching CAPE class until the 25th of October we started. They ended the same time like you. They ended the same time like you in the first semester for exams. Fortunately, I said to myself, you know what, let me do the calculus option first before I do the statistics option. And I'm so happy that I did the statistics option because I don't know what would have happened to me right about now. Right? Think about it. I have class with them on a Monday and a Friday. Good Friday, I missed their class. Easter Monday, I missed their class. So last week, Tuesday, I never had a class with them the Monday. And Friday of last week was the first time in 2 weeks that we have had a class. My next class, I had a class with them last night, finished about 10:30. My next class with them is on Friday. And what I do is invite them to my business calculus class on a Saturday morning and change up the business calculus, something when I teach, so that they can come to the class and get more help. So what I'm teaching on Friday and on Saturday, They're going to use that information for go write an exam on Monday. It's rough. It's rough, man. When I say it's rough, and I feel bad about it. And I spoke in a meeting today for the deans and the vice principals and the principal to hear. It's rough. And I'm not the only one complaining. There are others too that are complaining. It's rough, man. So, to be honest, don't extend no semester for me. Me, I will finish with UNO. Trust me, I will finish with you. And if I see that I need something, I'm going to say, here the plan, guys, here the plan, come. We're going to meet Saturday, about 10 o'clock to 11 o'clock, or Sunday, whatever time, we can finish. I'm going to finish. it. You are not my problem. No, man.
That sounds like a new trend now, sir.
No, let me tell you something, man. It is, I am known to go the extra mile with my students. Ask anybody who did in a class with me face to face. I was supposed to do that time, and no man, I got through cover, done the syllabus. But you know, it's just a rough period. And I know you two have it rough enough, but I'm going to say to you though, hear me out and hear me out well. Is it because I know how rough a semester it is? Last semester, while I was marking papers, last year this time, while I was marking papers, summer school started. So while I'm teaching summer school, I still have second semester papers to mark. It not happened to me this time around. It mashed up my headspace. And they know, trust me, when the institution has breathed down you, and especially when you're a team leader, and you can't go to your team members to ask them for exam papers because your paper outstanding too, I have to always produce my papers first. Hence, me saying to you last semester, me want to close out Edifice because I have to close out my process first, so that when I'm speaking to my team members, I can say, I have done it, you can do it also. It's rough, man. It's rough. But anyhow, I have been through rougher semesters and survived. This is when I happen to. But hear me out now. And this is my final thing before I project the answers or the answer. Hear me out now. It's whatever you guys need to do. When you need to do it here, I don't want anybody to fail my course. And already I'm concerned about a few of you. One, not coming to class, coming out to my classes. And then for all of you, the pace at which you are completing your Edifice is very slow. Now, hear me out and hear me out well. Love it, you know. Nobody can't talk about my calculus 2 students, you know. Crazy. Now, dipping it. All right? As I said, I remember over the weekend I heard of a situation where somebody was passing by and heard when two people in a dispute and just went to just pass peace, and the aggressor stabbed the man who was a peacemaker, killing. Right? But I just say this to say to you, my work on Edifice must be completed in a timely manner. And I want the work on Edifice to be completed before your exam. This is how generous I am. Before your exam. Have you gotten a copy of the draft timetable yet?
No, sir.
All right, I soon send it off to you. I want my Edifice pieces to close out, and trust me now, I want to hold me accountable to this, you know. It's just like how you can hold me accountable to make sure I'm marking papers and everything. My Edifice will close out before. Let me just give you a little piece of story. Last semester, I had to reopen Edifice for students of the class who just did not complete. And if I had done it, if I had used the averages on it, they would have failed the course. They would have failed the course. I'm not into them foolishness there. I'm telling people to redo this at that time. Let me look at the redos on Edifice before the exam, so I can give you a time frame in order to get it completed. I'm trying to help you work with me. When you go to school, I'm never going to teach you nice like this, you know. No ask you. So I'm saying, and especially at the university level. So I'm saying to you, before my exams, I don't give no date yet. Before your exams, my Edifice pieces must be completed. I've looked, I said where people start, but I said where many of you have not started, not even one. All right, with that said, let me project the solution to this question. All right, so some of you got it right. I've been looking at the WhatsApp messages. Oh, come on, don't do this to me now. I've been looking at the WhatsApp messages and some of you have got it correctly. So I'm really proud of you. Let me reduction this. One more. All right, take a few. Let me just find the timetable and send to you.
Sir, that's not the question. Why?
Next one, can you see what is happening now?
Yeah, man, sir, right, you know.
All right. So you see it right now, next one?
Sir, me come in, me never see the question in it, sir. Me just see it now.
Okay. Andrew, what is the now?
I see it, sir. Reach up to to the integration point, but I didn't go forward with the multiplying by 3 times by the 3. We get 21x minus 15 over 2x squared plus t. Yeah, that's where I stopped.
And I'm hearing that too. I'm seeing some people putting everything over 2. Be careful. It's just a 15 alone that is over 2. So be careful with that one. And I don't know what. Oh crap! It's not been downloaded now. Oh man. I found a timetable, but guess what? My phone is full, so it's not been downloaded for me to send out. Anyway, but by the end of class, I'll delete some stuff. By the end of class, I'll send a draft timetable to you. Come on now. Right. So look at that for me, please, and 2 more minutes. You ask me questions, and then I move into some stuff. Oh, 6 o'clock now. Matthew, I need to set off an exam on Edicasol for a lecture. Can you just watch a clock and just when it is 6:30, please? Our exam starts at 7. Please and thanks. Let me just get the exam people here now. This, you know what? I know what I'm gonna do. Charlene, do you have my email address?
Repeat, sir.
Do you have my email address?
Sir.
Who has my email address in the class? Nobody?
No, sir.
What am I looking for? Okay, save as. Yes, that one. Do you? Háblame. Do you? There you go. All right. Oh Lord Jesus. Send me an email, please, Rico. Yannick, wishful thinking. You think say if exercise with the money, me da come tell the story there. Would I take it first and then tell you? How will I go on with it? Would I take money first and then tell you? Rico, send me a message, please, an email, please, and I ask you to do something for me. Oh, so why don't I do that then? I can put the chip in the card so I can just transfer the information to the chip to spare some space. Oh, why did I do that? All right, cool. All right, are there any questions while I try and sort out for the, okay, let's at least, oh, you know, I keep doing this in it. Thank you, Lord. Okay. Oh, what is this? Oh, it's an answer sheet. All right, are there any questions, guys? Talk to me. Are there any questions? All right, fully understand, fully agree?
Yes, sir.
Yes, sir.
Yes.
Okay, good. All right, nice. Okay, so I'm moving into the final unit, final dege unit, which has many other units. I mean, many other topics in it, or plenty, enough topics. Need about 4 or 5 topics in it. The first one though is talking about a multivariable function, and why I like teaching this topic is it is a must-have. It's when I say a must-have, I mean a must-have. There is no way you can do an exam for Calculus 2 and not see this question. What am I saying to you? I'm expecting this question on the exam paper for full 20 marks. And if it's not there for full 20 marks, it's about 15 marks out of the 20 marks, and then you get another 5 marks up. Real talk. And even if you can do that 5 mark and you can get the 50 marks out of that, 15 out of 20 is not a bad percentage. Because if you go in one other question and can get 15 out of that, you have 30 out of 60 already. You pass the course. Because I suspect that you can pass the multiple choice. You pass the course. And come Thursday when I give you your mid-semester and you pass that, and you complete your editor's office for the stuff, Calculus 2 is behind you. You see how easy it is? So this course is a must-have. This topic is a must-have. Let me just look at the answer sheet to this thing right here, because I know what is going to happen. So it's a must-have. And I'm going to ask for your undivided just until I copy this answer sheet. Cut. Hold on a minute, please, guys. This is what we do. Sorry, guys, I'm just multitasking. I need to set off. Remember, somebody to remind me about this exam that I need to set off for my team member at 7 o'clock, but remind me at 6:30. So I just need to do that. All right, so that is done. All right, that is done. Thing to do. I think it will be best if I show you. Let me show you this. I think I prefer how I introduce it to the CAPE students than what I have for you. I think I did a nice thing to introduce this topic to the students. Applications of differentiation. What I need to do is just to, oh come on, cancel. I think I did a nice job here. This one, so let me just copy it and just put it into your document. Sometimes I don't always use the same information. And now it's something for them, so I just want to share that with you. Example stream. And multivariable calculus, that's you. Share screen, multivariable calculus, that's you. Let me do this. Paste that here. All right, and I need to do some stuff. All right. So let's see this document. So we're looking at some multivariable functions. I want your undivided. I don't care whether or not you're understanding anything that I've done before. That's not my concern at this point in time. Yes, it is my concern, but not at this point in time. What I'm concerned about at this point in time, this year, immediate point in time, is the fact that I'm starting a new topic, a topic that I expect you to get a full question on in the exam. You can learn this. You must learn this. You will learn this. So, those of you who are driving, keep both eyes on the road, one ears for them bad drivers, and give me the other ear. I want you to see it. I'm talking about first order partial derivative. First order partial derivative. A partial derivative is a derivative that is not complete, the partial. All right? And I'm going to also be looking at cross partial derivatives. All right? So I'm looking at first order partial derivative. I'm going to also look at cross order partial derivatives. And best believe I'm going to also be looking at second order partial derivative and the cross partial derivatives. All right? Now, all right, so 4x cubed y squared. All right, so I want to look at this one here. Yeah. All right, let's go. So we're looking at an example. I'm going to teach you this by using examples. I'm going to teach this by using examples. We know differentiation. Mr. Shan can tell you that you guys know how to differentiate. No, ask you. Telling you that you know how to differentiate. But we're talking about a partial derivative. That means something is not fully stated. Now watch me. When you are single, you do any darn thing you want to do. Nobody can tell you say you can't go nowhere and you can't do that. No boyfriend can tell you say you can't go nowhere. You're single. If he want to tell you say you can't go nowhere, make him put the ring on the finger. Similarly, no girlfriend can tell you guys say you can't go to her, you can't go to them, you can't. No, you have to go first, put the ring on the finger, right? So when you're single, male or female, if I'm not speaking to you, you're out of the way. If I'm speaking to you, you're into the picture. But you see, if you're married, you can't get away from it. Whether or not I'm speaking to you, you have to be there. Sir, oh, that coming in maths. Thanks for asking. Watch it. 4x cubed y squared. This is a marriage. Sir, how you know that? Because the x cubed is being multiplied by the y squared. Oh. Is this married or is it single?
Single, sir.
Single.
Thank you, man.
Yeah, man, single. And so is this x to the fourth, single. This y squared marriage. The one here, 40. It's single too, you know. But when I differentiate it, poor fellow, he not stand no chance.
Put up on the side, sir.
Yeah, man, not a chance, right? The one you do, you see the other one is single. If I'm not speaking to y, this one will stand a chance neither. If I'm speaking to y, yeah, man, the one can stay. The one here, if I'm speaking to x, it's fine, but if I'm not speaking to x, maybe I should quit. Whether or not I'm speaking to this one, I have to throw it out because the differentiation of a constant is equal to 0. So that one understand nothing. That one is, that one is a little fish that got birthed, but guess what? Him so weak and frail that no matter how fast him try to swim, a tadpole, a crab, or something they eat him. Him not have no chance to survive. The one here, on the other hand, can survive when I talk about y. The one here can survive when I talk about x. But this can survive when I talk about y. can this survive when we're talking about x? Sir, you know, that's what we're talking about, sir. Not a problem. So let's just remember what I want you to remember for now. When you have a product, x times y, I am saying to you it's a marriage. If I come to speak to the wife, best believe that the husband has to be a part of that conversation. And especially if we talk about money and rate, right? The husband should say to the wife, you know, XYZ, or the wife to the husband, you know, XYZ, because the two is one. Now, if me is single, whether or not I want to bathe, or to cook, or to clean up the house, it's my prerogative. But if I'm married, I have to recognize, say, I can't leave these dirty clothes in the place because I expect somebody else to come in after me to use the bathroom or to use the kitchen or so forth and so. So I have to be very mindful. Watch me. Watch me. Don't blink. It's first order partial derivative. So the mere fact that you hear derivative, it suggests that I'm differentiating. All right? Watch. 4x cubed y squared. It says given that f of xy, it's a multivariable function. Multivariable. Multi means many. You have two variables. Now, if I were teaching, I saw where Wind sent something in the group about different levels of calculus. Yeah, man. So if you go to calculus 3, you would move on to another multivariable function, which is x, y, z. Oh, Rockstone, but you are going to be doing that. X, y, z. You are going to be doing in SIN matrix something that involves X, Y, and Z, right? So what's up, my do? Jesus, save me. Right? So when you're doing Hessian matrix, when you're looking at the Hessian matrix, you're going to go back to the 3x3 matrix, and we're going to be looking at a function that possibly contains, see, compute the Hessian matrix for the function f of x, y, z. So it's multivariable. Right?
So that is what? Calculus 4?
No, 5. Right? So this here is preparation for what I'm doing now, is preparation for this topic. It's preparation for that topic that we're about to begin. All right? So look at what is happening here now. So in this here case, we are only concerned with x and y. So you have your multivariable function look so. Watch this. I'm differentiating with respect to x. See here, evaluate f subscript x of xy. It means that I'm differentiating the function with respect to x. I'm differentiating the function with respect to x. All right? Of xy. The one here says I'm differentiating the function with respect to y. Now watch me. When I'm differentiating the function with respect to x, it means that y is a constant. When I differentiate the function with respect to y, it means that x is a constant. When I'm differentiating the function with respect to x, y is a constant. When I differentiate the function with respect to y, x is a constant. Just bear that in mind. Disclaimer. Watch me. I'm differentiating 4x cubed y squared with respect to x. Which one is constant then?
Y
Y
squared.
Y squared. Very good. Nice. Nice job. All right. So watch me now. So in this case, and I'm doing the question 2 ways. I'm doing it 2 ways. I'm going to show you the way that I showed you how to differentiate a product in calculus 1. But this way, I do not want any of you to do it. All right? But I'm going to show you just to refresh your memory. The first times the differentiation of the second plus the second times the differentiation of the first. The first is 4x cubed, see here? 4x cubed times the differentiation of the second. No, because I'm differentiating this with respect to x. it means that y squared is a constant. So I'm going to have 0. See it right here, so? Then plus the second is y squared, see it right here, so? Times the differentiation of the first. I'm going to differentiate the first. I'm going to get 3 times 4 is 12, 12x squared. And that's how I get my 12x squares right here. All right? Then 4x cubed times 0 is not. And then y squared times 12x squares is simply going to be 12x squared y squared. See here? 12x squared y squared. Tell me that you see what is happening here.
Yes,
Yes,
sir.
sir.
Sorry, can you go over that again? I don't. Where did they get the 0 from?
The differentiation of the constant y. Remember, I'm differentiating the function with respect to x. So anything with y is going to be a constant. The differential of the constant is 0. So let's go again. The differential of the first times the second plus the second times the first. The first is 4x cubed times the differentiation of the second, which is y squared. And y squared is going to be a constant. Why, sir? Don't you get 2y? No, because I'm differentiating with respect to x. So the differential of a constant is going to be equal to 0. So therefore, that's why I get that 0 here. Then no, plus the second, which is going to be y squared, times the differentiation of the first. And when I differentiate the first, I'm going to get 3 4 12x squared, which is this. 0 times anything is 0. And y squared times 12x squared is going to be 12x squared y squared, which is what I have right here. Comprende?
Yes, sir.
All right, good job. But I'm not someone wanting to do it. That's how I taught in first semester. First calculus 1. And that's someone want to do it. I want it to be the grown-up way. The grown-up way. Watch it. Watch me. Which of these is constant when I'm differentiating with respect to x again?
Why?
Y squared. Right. So it's going to be y squared, right? Good. So I want you to call the full term. Yes, you're correct. That is y. But I want you to call the full term. Say to me, y squared, sir. I want to hear y squared. And I'm going to tell you why. You see, when they say to me y squared is constant because I'm differentiating with respect to x, I'm going to put back the y squared right here. So see the y squared right here, so I'm drawing back. This y squared, all I did was to put it back right here. This method is a recall. Let me just put it here. You call it for the rule? That's the recall. This here now is a grown-up method. Watch me. Watch me. This is a grown-up method. And the grown-up method is I'm differentiating here with respect to y. Because I know my y is the constant. My y is the constant. I'm putting back my y squared here. So why put back the y squared? Never to put 0. Because it is married. Can't throw it out. So if husband and wife not, wife can't say come out of my house. It does not work like that. Neither can husband say come out of my house. He can come out of the room and go to our next room. But he can't come out of the house. They are married. So because they are married and you not talk to y, you go park y is still there. So see here, put him back. Then I'm differentiating with respect to x. When I differentiate 4x squared, cube, I'm going to get 12x squared. So I put my 12x squared right here. Do you see that this here comes out to be exactly the same thing as this right here, son?
Yes, sir.
In a much shorter time and more efficient way of differentiating? That's what I want. All right, watch me now. Let me just finish the story. So continue the story now. I'm differentiating this with respect to x. What do I get?
0.
Nada, nothing. So I just dash it away. And then I'm differentiating this now with respect to x. Of course, I'm differentiating the whole function with respect to x. When I differentiate negative x to the fourth, I get what?
Negative 4x squared.
4x cubed.
Negative 4x cubed. I heard that very faintly, but yeah, negative 4x cubed. Now watch this now. Remember, you know, that when you're married now, you know, and I'm differentiating. Oh, sir, the y squared is constant, so we're just going to put him back. See here? I put him back because I can't throw him out of the house, or I can't throw she out of the house. You understand? So I put him back. Watch me now. I'm differentiating 9x. When I differentiate 9x, I get what?
9.
9.
And I put it with the y squared, and it's done right there. So let me say it not easy. And guess what?
If you
And
hear
guess
right,
what?
no,
Ouch. But I'm going to tell you something. You see, in this case, this is a case when Sasha and Yannick and Charlene take me on. Say, and Andrew, you know, the whole
the easy one. This
yeah, all they say, yeah, man, sorry, the easy one is, but I can guarantee you something. I promise you that I show you into the differentiation all the time for this topic. There's nothing harder than this. A same way, so you're going to do it positive. I guarantee you.
And this mandatory SSR?
And me to tell you.
All right.
And me to tell you.
2.
Me to tell you. It's not going to be hard.
3 points.
All right. So so can I just tell you so? Ouch. Can I just tell you something? And it's a humble request. You don't have to do it. It's just a humble request. You see, when you go into the exam, look for the topic here first and do it and put on your 15 marks or your 20 marks out of 20 and put it up first. Don't wait for last. Come in at one time, run up on you, and then no, you get only 10 out of the 20 or 10 out of the 15. More when you get the full marks. So, and that's how you do exam, students. You look for the questions that you have most information about so you can get them out of the way. You spend less time, and then you spend the rest of the time on the questions that you don't know what to do, because questions you don't know what to do, you spend too much time on that. And the ones that you truly can do, you just have limited time. So one humble request is when you go into the final exam, look for that one first. Do it. Get either 15 marks. You know, think them over here 10 marks. Get you 15 marks, get you 20 marks, and put it up and say finished. I have 2 more questions to do. There is no exam paper that I have seen in this recent time that does not have a question on this. All right? Okay, since you are by me, all right, we're gonna look at you, man, and I'll pay you no mind, man. You go on, enjoy. Send that one more time. All right, let's go. Now, and of course, the differential of a constant is equal to 0. So that's why this one ends right here. Watch me now. Watch me. I am going to differentiate it now with respect to y. These are first order, you know. First order just have one x or one y. Second order, we have 2 x's and 2 y's, or an x and a y and a y and an x. That's what we call cross partial, right? Cross partial is when you have the 2 of them mix up, the 2 variables they mix up, x and y and x. All right? And we have a nice little story to tell you about this one too. Let's just go with the f of y. F of y of x, it means that I'm differentiating y with respect to x. It means which one is constant?
X.
Yeah, man. See, we understand the topic already. X is constant. Watch me. So if x is constant, that means this 4x cubed, I'm going to write back. Watch me. See here, so I'm going to write it back. 4x cubed, right back. I can't trouble you because you are married, so I have to make you stay right there. Then I'm going to differentiate the y squared. Differentiate y squared, I get 2y. Talk truth.
Talk truth.
Yes, sir.
Teacher, so I get my 2y times 2y plus. I'm differentiating this with respect to y. Yeah, man, this can differentiate. No. 5 to 10y. See the 10y here? When I differentiate this, what I get?
0.
0.
All
right, so I throw it out. Single. Now talk to you, you can't come out of my way. But this one here is marriage. I'm differentiating with respect to y. That means my x is constant. So this 9x, I have to put it back. See here? I just put back the 9x right here. So, and then I differentiate y squared, and we get 2y times 2y. And of course, the differential of a constant is equal to 0. Now, why this here is in 2 lines is because I could do it one shot, but I want to show you what is happening. Now, 4 times 2 is this 8, x cubed y. So that's why I get this here. My final answer, the 10y is 10y. And the 9 times this 2 is the 18xy. It's done. Tell me that you see it.
Clear as mud.
Yes, sir.
All right, good. Let me tell you now.
And this is 20 marks, sir.
All right. So the methodology will include 20 marks. I am going to ask you to do a little bit of mathematics to it. So normally, the first part of this differentiation that you're going to get is when it carries 6 marks, right? And if it's a 20 marker, then I'm going to ask you to do, you get 40 more marks to do something. So this here is an optimization question, right? So you are the product manager, purchasing manager, big shot person at say Lasco, right? And you are now working with 2 variables, 2 products, 2 of the newest products on their market. And you are saying, okay, fine, so far, I am going to be, doing some stuff, and we're going to write an equation, and the equation that we get to match f of xy is going to be the one that is on screen here, so, right? You are now need to optimize to see how many of one you should manufacture versus how many of the other you should manufacture. So case in point, let me give you another example.
Excuse me, sir.
Yes, Papa.
You told us to remind it of 6:30.
6:30. All right. Thank you, sir. Thank you, sir. Thank you. Let me. All right. So while I do this, I will talk to you about it. All right. So put this in your headspace and tell me if you see where I'm going with this one. Say for example, you own a phone company, a franchise, Flow or Digital, whichever one. It doesn't matter to me. And you recognize that the little schoolers, them are coming now, them not buying no Android, them want Apple phone. Would you stock on a lot of Androids or will you stock up on a lot of Apple?
Apple.
Apple, sir.
Yeah, Apple.
Apple.
Good, because you don't need to do your market survey to see what is happening, right? But of course, you can stock up on a little what do you call it now? A little banger smartphone, if you do have something like that. The banger smartphone, then the one them kind of look cheapish, you can't use a big finger and touch nothing. I touch all of the key them on it, yeah. But you are going to stock up when you do your inventory on those products that are going to be selling, because your aim is not to keep anything on the inventory too long. You want to sell so it is that you can get more. This is exactly what we're doing. We're optimizing. So when you look at your syllabus, it talks about optimization, but we don't want to use them big words to scare you. So I'm taking it into sequence. All right.
Sir.
Yes, Papa.
Just one little thing more, just get some clarity for that again.
Mm-hmm.
When for the first one for fx, 5y squared, why it doesn't become it's constant? That's why it's 0.
Yes. When you differentiate,
or it's not y to anything. It's not y to anything.
No, man, no. It's y to not things. Y to the second power. But because I'm differentiating with respect to x, it means that y is now a constant. Yeah.
Okay. All right, sir.
Yeah. Put it this way. I'll come into you, honey. Put it this way. So when I'm traveling to the States, may like to have some Jamaican dollars with me, because the truth is, even though I may be driving myself or be driven to the airport, I go to the airport, and especially if I'm going to Montego Bay, I don't want to start using my US dollars in Jamaica. Hell no. Crazy. Me say 1 year, me feel one lump on my throat. When me say lump at my throat, if me just swallow, me start cry. Why? Because I rented a car, paid for the car from out here, clear the bills and say, all right, this is X amount of money I have the maximum amount of money to spend. When I reach now, the people them say to me, oh, this is all these luggage belongs to you? I said, yes, miss. Oh no, the car won't be able to do that. You have to go to a truck. I was like, excuse me? Yes, sir. The car won't hold that. And she adamant she now process me now. I said, John will start. Why make sure say the luggage them? And I cuss and I rant. I'm cussing myself, And I vex. I said, okay, give me the upgrade. She said that is going to be, like, should I say $80 more? I said, how much? They said, I don't even reach foreign good yet, and I $80 I'm spending more on top of what I spent. She said, well, that's what you have to do. I said, okay. And I said, guess what? I'm going to pay the $80 in on this. But one thing I will guarantee you, you will never, ever, ever catch me in this regard again. Not in this light again. Not in this light. You'll never catch me again. And then as we drive off, I said to myself, oh God, just imagine every week I have to put in $60 worth of gas in the summer. And I was just very depressed. But fortunately, the vehicle was very fuel efficient. It's like about $25 at most. Don't pass $30 to fill up. So I never complain too much. The point I'm making is you don't want to start doing something yet before you're reaching to the meat of the matter. All right? You don't want to do that. Watch what I'm going to do right here, so. Watch what I'm going to do right here, so. You want to maximize. That's the point I'm making. Try to maximize what it is that you have, right? Let me just go back to the document. I'm trying to multitask. Let's just look at this. So remember now, it no matter, it is enough money. So I was saying to you that I have Jamaican dollars in my pocket. And I have the Jamaican dollars, should in case if I'm flying out from Montego Bay, I can buy a meal if I want a meal. Or if I don't want the meal and I'm not spending the money, I put the money in my pocket. Chances are when I come to Jamaica, God forbid, if there's a delay in the flight and I don't want my people them to come out in them wee hours here to come pick me up, I can maybe charter something or anything can happen. Me just very tired and I want to give the tip the little bellman them a little money. I have Jamaican dollars, right? Point is, when I go to the States with my Jamaican dollars, I cannot use my Jamaican dollars in the States. So I'm saying this to say to you, whether or not it's y to the 0, it could be y to the enough something. I can't use it because it's not part of what I'm supposed to be using. And best believe, when me come on Jamaica, me come up with like $150 change, or even $1. Me not take up the US money and give the bellman them, but I'd rather give them a 5,000 Jamaican dollar bill. Don't ask me, sir, that don't make no sense. I'd rather give my Jamaican than doing the US, because the US every day the rate goes up for me to buy. So that $1 that I would spend $150 to buy, 3 months on the line when I want a $1, I have to pay $160. You understand? So it comes like real gold. Point I'm making, it no matter what the y is, it don't have to be y to the 0. Once I'm differentiating with respect to x, that y becomes a constant. All right? Watch me. Watch me. I'm going to do this one because I have many more to give you to do in class today, because what I want to do is to try a real one to show you what it looks like. Given that f xy is equal to all of this, evaluate f subscript f of xy and f subscript y of xy. All right? It means that M1 to differentiate with respect to x and with respect to y. Remember, when I'm differentiating with respect to x, the y is constant. When I'm differentiating with respect to y, the x is constant. Simply put, when you see this subscript down here, so it means the other one I'm differentiating with respect to, and the nether one is constant. That's all. Nothing too grand. So let's go. Hear me out. I don't want to show you what I'm doing yet. I just want to do it on orally first, and then we can talk about it pictorially. Oh, glory. All right, let's go. Ryan, and now for you, no mind. Last week, Tuesday this time, I saw a nice bean. All right, let's go. All right, good. 2xy. I'm differentiating 2xy with respect to x. It means that I'm going to keep my y constant. I'm going to put up my y over here so and differentiate the 2x. When I differentiate 2x, I get 2. That means this differential is going to be 2y. Talk truth.
Yes, sir.
Come on.
Yes, sir.
Come on. Watch me now. So just remember, so this first term is 2y. Eh? Watch me now. I'm differentiating here with respect to x. It means that y is constant. I take out my y and I put it down because I can't trade out. Then I differentiate my 5x squares and I'm going to get 10x, don't?
Yes, sir.
So this term becomes 10xy, don't?
Yes, sir.
Yes,
All right,
sir.
good. And the 1 year no. And remember the negative sign is very important. But the 1 year no, differentiating with respect to x, I take the y square, put it down. Then differentiate 6x. And when I differentiate 6x or negative 6x, I'm going to get negative 6. So you get to be negative 6y, don't it?
Yes, sir.
Yep.
Watch me. You see that? I don't need to write 2 lines to that because the one shot something. Let me go again. I'm differentiating this with respect to x. That means y is constant. I take the y, I put it back. That's the y I put back. When I differentiate 2x, I'm going to get 2. See the 2 right there, so? Bam. The 1 year, I take the y and I put it back. Differentiating 5x squared, I'm going to get 10x. I put the 10x in front of it. I differentiating this now, put back the negative sign. This y squared constant, I put it back. When I differentiate 6x, I get 6, I put it right there. So
Negative.
done. Negative 6y squared. Done. Then it says now to differentiate f subscript y. So I now need to differentiate this function with respect to y. Now remember, if I'm differentiating with respect to y, it means that x is a constant. All right? So let's go. The same function, you know, and the same function, but I'm just differentiating with respect to x. Let's go. I'm doing it 2 times. One orally, and then the other one pictorially. All right? So let's go. I'm differentiating with respect to y. That means my x is constant. 2x, I put it down. Differentiate y, I get 1. 2 times 2x times 1 is 2x. So that means this term is going to be simply 2x. The 1 here, I'm going to put on my 5x squared because it's a constant. Differentiate the y, I get 1. That means this term is 5x squared. The 1 here, I put on the negative 6x because it's a constant, negative 6x. Differentiate y squared, I'm going to get 2y. Negative 6x times 2y is negative 12xy. See it here, so negative 12xy. So you see, sir, that sir is able to do the differentiation in my headspace. Now, let me tell you something. You have done much more calculus than the CAPE students. And I taught the CAPE students this topic in about half an hour and catch it. You are more advanced than the CAPE students. You have done so much more calculus than they would have done. All right? They caught it in about half an hour. Do whole heap of big questions too. The same sort of questions that you are going to be doing. So I know you too can do it. Guarantee you, positive. Now, let me do it the last time now and show you the stuff pictorially. I'm differentiating with respect to y. That means my x is constant. This 2x, because it's a constant, I write it back. When I differentiate y, I'm going to get 1. Plus, my 5x squared is a constant. I put it back. And when I differentiate y, I'm going to get 1. My negative 6x is a constant. I put it back. When I differentiate y squared, I'm going to get 2y right here. So all I do now is just fix up this. 2x times 1 is 2x. 5x squared times 1 is 5x squared. Negative 6x times 2y is negative 12xy. Simple, don't?
So if he's gonna could
There must be more, sir.
sir.
There must be more.
Sir, what's the trick?
That's
What's the
Gabby.
trick? All right, okay, no problem. All right, all right. Remember, you know, if there's no trick to it, we're not going to bang a bag of tigers, you know. All
And
right.
he's doing the second person.
All right, let's go.
Shrimp flap say I get sir.
Blow, you're so nice. Yeah, man. All right, do me a favor. Sash, you asking a question, honey punches?
It sounds like Yannick, sir.
Oh, sorry, Yannick. Okay.
Yes, I may ask for the trick. For the trick.
Leave me alone, not sure. You shall leave Sasha and Cameron. I'm not always a trouble teacher. No, man, there's no trick, man. I promise you. All right, let's go.
Hold on. I'm get group in there, so.
How you get group? Because you always have. It's all right. Never mind, Andrew. It's all right, man. I saw you say, no, Andrew. Sir, where is the trick in this, sir? There is no trick. Trust me on that. Let's go. I am leaving you this in 2 minutes to do the differential here for me. F subscript f of xy, f subscript y of xy. 2 minutes. You don't know who I'm going to call upon. So it means that all of you have to do it. I am just going to get a glass of water to wash down the niceness of this stuff and come back. 2 minutes. Did you? What is the differential with respect to x?
We are, sir.
Did you?
Sir, who names so, sir?
Russell?
Oh, sorry, sir. David stepped out just now. She'll be back shortly.
Oh, you know that.
I'm right here at the laptop. She left the room.
Oh, I'm sorry. I thought that was Andrew in your class.
No,
All
I
right.
don't want to keep you waiting. You asked David, so I'm just
Yeah,
answering.
yeah, man. Got you, Papa. Got you. And I'm supposed to be doing something for you. So read that course. All right, never mind. No problem. No problem. No problem. That's fine. Aviana, what do you get for f subscript f?
Sir, I have 12x y cubed plus 8y to fourth power minus 10xy plus 2y.
Is she correct, guys?
Sir, it's too good to be
No,
Yes,
sir.
final, sir.
Yes, sir.
Yes, sir.
No, sir. No, sir.
I mean,
No,
no.
sir.
I mean, she right, man. Girl, good, man. The good. Nice.
Sir, may I do the question? May I say, this not look like it finished.
Sir, hold on, sir. The plus 2y, isn't that supposed to not be there?
Yes, sir.
She said plus 2y?
Yes, sir.
No, but she not good. She not right then.
The plus 2y is zero.
Avi, fix up the something, man. I make me get all excited. Fix up the something, Avi.
It's partially right, sir. This stuff out there.
Yeah, one day.
Avi, fix up the something now.
Sir, sir,
Mm-hmm.
sir.
Yes, Sonia, I'm hearing you.
So what you say is this is the question and that is the answer. Them two lines the way you saying it worth 15 marks.
In Jesus' name, you need Gordon. Leave me alone. No, man, I'm coming, man. I'm building. I'm building. I'm building. No, man, you don't have to worry, man. Trust me.
Less marks. So me make sure, sir. I say it go for real.
No, man, you're good, man. I promise you, you're good. Aviana, talk to me now.
Sir, say would we go to the 2y would have been 0 instead?
Right, because you're differentiating with respect to y. If it's with respect to x, yes, it's going to be 2, it's going to be 0.
All right, sir.
Good, nice. So we get that sorted away. Very good. Let me see now. Sean Anderson, we want you to do a subscript y for the teacher, you know. Mr. Anderson. Yes, miss. I asked my students today. I'm going to release the exam now for you. All right, cool, no problem.
Sir, since now I'm going to get a bite out my
Dropbox, yeah. Mm-hmm. Cool. All right, go ahead, Ryan.
For the second one, I have 18x squared y squared plus 32xy cubed minus 2y.
Look at it, minus what?
2y.
Okay, you give me the last term.
2y.
The first two terms are correct. You're struggling with the third one.
Is it 5x squared plus 2y?
It's just plus 2, Ryan.
Just plus 2. Yes,
okay,
plus 2.
Okay.
Plus 2. But guess what? If you can get them first two part right, you know, that's nice. Very nice. Very, very nice. Keep up with the good work. Very nice. All right. So those are the solutions. All right. Plus 2. Let me ask a question. Is there anyone in the class that is not seeing it? All right, I'm not killing it. So I'm going to jump question example 4 because I'm not killing it. You will get them nonetheless, you know. I want to move into the second partial derivative. That was the first order partial derivative. Sir, we know that there was a trick. There is no trick. At the same something you're doing. I guarantee you, it's the same something we're doing. All right? Second order partial derivative. All right. Now, let me just talk to you about this notation here. F subscript x. I want you to look at that. F subscript x. You know, we talk about the f and have the subscript x down the bottom here. This one here is one way of writing it, or I can write my squiggly d over my f of xy over my squiggly x. Sir, squiggly d and squiggly x. Yeah, man. When you see me talk about the squiggly d and the squiggly x, I'm speaking about something that is a partial derivative. It's just another notation that I want you to see, because I don't want, if the man them going at the exam and give it the squiggly notation against a sir never teach you that topic here. When in truth and in fact I would have. So the squiggly d is just showing that it's a partial derivative. So I can either write f of x comma y, that you know that is a multivariable function, that is when you take a partial derivative, or I can write my squiggly d over my squiggly dx. All right, same difference, same difference. All right, now what I want you to do is and it's the same thing. My f subscript y of xy is, I can also incorporate it in my squiggly d. I can also incorporate it in my squiggly d. Let me just set up this assessment, please. 1 minute. Answer for this. Upload file. Half a second. Selected date. Today is how much? The 26th. Lord, I'm not done. Let me just double check on this thing. Yeah, so the second partial derivative, let me just talk to you about that a minute. So the second order partial derivative is really talking about finding the second differentiation, just like how we did the second differential of, you know, other stuff. It's just a second differential we're talking about. Really nothing too fancy. So we must have the first differential before we can go ahead and do the second differential. We must have the first differential before we can go ahead and do the second differential. That's all we're doing. Nothing more to it than just that. We must have the first differential before we go ahead and do the second differential. All right, must have the first before we go ahead to do the second. All right, let me just attach this thing here. Choose file. All right, now what we're going to be doing here is to do a quick example, a very quick one, on my second order partial derivative. Spend some time looking at the first order. You see the first order. You see it's not difficult. I'm going to now ask you just to go ahead and just work on the second order partial derivative for me. Look at this one here. One quick example. It says for us to find fxx of xy and fyy of xy. Oh, okay, sir. Do you have to find f subscript x first and then find the differential of it again? Very good. Yes. So to find the second order partial derivative, you have to first find the first order partial derivative and then differentiate it one more time with respect to x. You do the same thing for y. This is just like how we were finding the second differential. Remember when you're finding the point of integration?
That, sir.
Yes, man. At the same thing. Now, guess what? I want to see how well you remember, you know, if I teach you how to do partial derivatives, you're supposed to be good to go with this one. So I'm leaving you now. When I say leaving you, I'm not leaving you necessarily, but I'm going to ask you to go ahead and find the first partial derivative with respect to x and the y of the function. And then I'm going to ask you to find the second order partial derivative of each of them again. So I'm giving you that to do as a classwork right now. That will take us up to 7 o'clock. Go ahead and find the first order partial derivative. When you find the first order partial derivative with respect to x, you're going to differentiate that function again with respect to x, and that will give you the second order partial derivative. You do the same thing for y. On your mark, get set, go.
Here we would complete the fxx first, and then we do the fyy.
Yeah, you could do that. I have no problem doing it that way. Yeah, you could go ahead and do that.
Sir, finish, sir.
Okay, nice. Sounds good. Anybody else finish? Oh,
Yes,
sorry.
sir.
Yes, sir.
Oh, nice. Nice. All right. Hold on. Let me project the first order answer first. Look at the first order and tell me if you agree with that. Are you seeing my screen?
Yes, sir.
Yes, sir.
Do you agree with it?
Yes, sir.
Yes, sir.
Boy. All right. Ready for the grand review? You tell. I trust you. I know you're honest students, and you will tell me whether or not you got it. Second order partial derivative. Do you have that?
Yeah. Yep, sir.
No, sir.
What? Where went wrong?
No.
So you got the first order right though, right?
Yes, sir.
What?
Yes, sir. Get it right.
Nice.
Sir, all right, for the first, the XX.
All right, hold up, Karika. 1 minute, honey bunches. So you're saying to me that what I have in blue here, you got correct?
Yeah.
Okay, good. So all you need to do now is to differentiate this again now with respect to x to get xx. So f subscript x is this. In order to get xx, you will differentiate this same function again with respect to x in order to get xx. So let's go. You differentiate.
Hold on, sir. We're differentiating the new function. That's what you're saying.
This function, yeah. You're differentiating this function. Remember, no, in order for you to get d squared y by dx squared, we have to differentiate dy by dx, not the original function. So we have to differentiate the first derivative in order to get the second derivative. Now, this here is the first derivative. See here? First order differential. First order, first means first derivative. Second order means second derivative. Single number down here is a subscript, first differential. Double number down, double something down here, so second differential. So differentiate this now with respect to x in order to get the derivative. So x, that means the y squared is constant. I put back my y squared. And differentiate this with this x, I'm going to get 24x. It's going to become 24xy squared. Bam. Differentiating this with respect to x one more time. 3 times 4 is 12, negative 12x squared. See just so negative 12x squared. This is y. Differential of this is 0. Go away. You're done. In order to get my y, I'm differentiating this first differential with respect to y. It means that my x squared, my x cube is constant, my 8x cube is constant, so I write it back. And when I differentiate y, I'm going to get 1. So 1 times 8x cube is 8x cube. When I differentiate it with respect to y, I'm going to get 10. See it right here. So and when I differentiate this with respect to y, my 18x is a constant, so I write it back right here. So and when I differentiate y, I get 1, and 1 times 18x is 18x. And it finishes right here. So follow me?
Yes, sir.
Okay, I had 2 errors in mine, sir. I had to correct it.
All right.
But yeah.
Which class do you have now?
Sir, accounts, and I guess you need to go now.
Oh, you have an exam now?
No, sir.
Okay. All right. All the best. We will go ahead, hon.
When I was doing it, I do like the fx, the first order, and then right after the first order, the second order, but I did not separate them like this. That it will look okay?
Yeah, man. So you did the first order, then the second order, and then this one, and then this one?
Yeah.
That's how I
Yeah,
did
yeah,
it too,
yeah,
sir.
yeah. That's fine. Perfectly fine.
That's fine. That's
All right. All the best, guys. Talk to you on Thursday. Remember, we're testing on Thursday, but I'm not testing you for 3 hours on Thursday. I'm testing you for about an hour on Thursday, and we're using the other 2 hours to finish off our multivariable. So I may do
How
the
many
multivariable.
questions, sir?
Maybe about 3 questions.
For the test?
Okay.
For the test, yeah.
Mid-semester?
Oh, wow.
Mid-semester, yeah. So we're getting it on Thursday, and I made testing for the last hour of the class, so I can use the first 2
Yes,
hours to
sir.
finish
Yes,
teaching.
sir.
All right, cool.
All right,
Bless your
sir.
heart. Take
Thanks, sir.
care. Cool, cool.
Okay, sir.
Mhm.